Let's take a look at solving equations with roots, and those roots could be even or odd powered. There's a variety of looks that you have. You can have a root, here's one that's a cube, and a number. We'll have to move that number over before we do something. A root exactly equal to some x value, so we need to, there's an x buried in here, we have to get at that somehow. Here's a root, and the other side's an expression, not just a variable, and then you have equations that have two roots in them. And so let's take a look at each of these four scenarios and see what we can do. With the first one, it's a cube root. We're going to go ahead and add 1 to both sides. And that means on the right-hand side, -5 plus 1 is -4. On the left, we get 2x minus 2. Let's go ahead and rewrite that as a rational exponent, because what we want to do then is cube both sides. Sorry, keep that negative in that cube. When you take the cube on the left, the 1/3 times the 3 gives you 1. So what's inside that root pops out, and that's how you decide what power to raise it to that's in red. You want to get rid of the rational exponent. On the right side, 4 times itself 3 times is 64. The negative stays because it's an odd times of multiplying, so you get -64. Now we just have a linear equation. Add 2 to both sides. You get 2x equals -62. Divide both sides by 2, and you get -31. Now, does this work? And so you do need to check when you do radical equations. So let's go back up to the beginning. 2 times -31 is -62, minus 2 is -64. What not number times itself 3 times gives you that, -4. So -4 minus 1 is -5, and we're done. That's with odd roots. So an odd root, the variable can be positive or negative regardless, but be careful of these signs and these odd and even roots. For the next one, it's a square root. Because it's a square root, we could convert it to a 1/2, or we can just say, I'm going to square both sides, because a root times itself, when it's square, is equal to what's inside. So you get 5 minus 4x is equal to x squared. Well, it's not linear, and so let's move everything to one side. I like to have my squared term be positive, so I'm going to leave that. Add 4x to both sides. Subtract 5. And now you're left with solving a quadratic. You can use a quadratic formula. You can graph it. We're going to go ahead and factor this thing. Can we factor it? This is saying that both factors have different signs, and this is saying the larger product is positive. So let's do x. We know the first term has to be x. 5 and 1, it's a prime number. You can only have 5 and 1 as the factors. The larger product needs to be positive so that when we FOIL it, x squared plus 5x minus x is positive 4x, so that works, minus 5. Now you set each factor equal to 0, so we get x equals 1. This is using the 0 property. Now let's go back and check each of those. Do each of them work? So put a 1 in. 5 minus 4 times 1 is 4, so the square root of 1 is the square root of 1 equal to 1. Yes, so this guy works. Now take a look at the other one, -5. 5 minus 4 times -5. So that is positive 20, 25. The square root of that is 5. Is 5 equal to -5? No. So this one gets thrown out. The only solution is 1. This is called an extraneous solution. That's why we check these. So now we have a square root again by itself, and you do have to have the root by itself before you start doing anything. We are going to square it. On the left-hand side, we get x squared minus x minus 2. On the right side, we get x plus 5 times itself. This is not x squared plus 5 squared. It's x squared plus 10x plus 25 by FOIL. Let's go ahead and subtract x squared from both sides, and then let's subtract 10x, get that on one side, and add 2 while we're at it. Could have moved them the other way. Sorry, negative 11x is equal to, because these add to 0, these add to 0, 27. We're going to have a really ugly number here. Let me go back and check. my work to make sure that's right, because you always check it if it looks a little ugly. And so we squared both sides, got x squared minus x minus 2. On this side, x squared plus 10x plus 25. That's good. Moving everything, so subtract 10x to get negative 11x. Add 2 to both sides, you get 27. Divide by the negative 11. And yeah, so now you have to check that. So put that in your calculator if you would like to and don't want to do it by hand, and check and see if that's a correct solution. This last one now is probably the ugliest one that we will come across, and it's equations that have 2 square roots in them. Now we don't want to just square this side, because when we multiply this by itself, we're going to end up with a mess, these two guys, for the FOIL process. So let's move this to the other side. When we do that, we get square root of 2x plus 7 is equal to the square root of x plus 15 minus 1. Now we square each side. That's going to allow us to get rid of that root on the left. On the right, we're going to multiply the square root of x plus 15 minus 1 times itself and see what happens. So on the right, we get 2x plus 7, and on the left, sorry, and then on the right, we multiply this. This root by itself gives you what's inside. And then we FOIL, minus times this, minus 1 times this. So we get minus 2 times that root. And then negative 1 times itself is positive 1. Boy, it looks worse, but don't worry. Let's collect like terms on the right. We get 2x plus 7 on the left. And on the right, we get x plus 16 minus 2 times this root. Let's collect like terms by subtracting x and subtracting 16 from both sides. When we do that on the left, we get x minus 9, and on the right, minus 2 square root of x plus 15. Well, now you have a decision to make. And do you want to divide by that negative 2, or do you want to go ahead and square both sides? And there's schools of thought for both. I'm going to leave it where it is right now. We're going to square both sides. When you do that on the right, you get negative 2 squared, and you get the square root of x plus 15 squared. So on the left, x squared minus 18 plus, 18x, get rid of that one too, 18x plus 9 times 9 is 81. On the right, you get 4 times what's inside that root, and then x squared. Let's simplify the right side. We've got a quadratic, so what we have to do is get all the terms on one side. So let's go ahead and subtract 4x and subtract 60. When we do that, you get x squared minus 18 minus 4x is negative 22x. 81 minus 60 is plus 21. At this point, now you have options, and the video is about solving these. I'm going to stop at this point and tell you what you need to do next. Our options for solving quadratics are factor if you can, graph it, and the quadratic formula. So you have to decide which one of these you want to use. The factors of 21 are 1 and 21 and 3 and 7. This sign tells us that the signs of the factors are the same, so we need the factors to add to 22. That is going to be 1 and 21, so you can factor this, so go ahead and factor it. Find the roots, test the roots, keep the ones that you want to keep. And so that's it. Hope you're having a great day.